Aku bosan lah. Tak main download lah.
Jom. Tapi itulah, kita tak ada dadu. Macam mana
Macam mana
Aku tahu.
Assalamualaikum and good day to everyone. My name is Muhammad Khairil Azim bin Azamuddin, and today I'm gonna explain about our project called Rolling Dice using the HCS12 board. So as you can see, this is the Dragon board HCS12. So the first output is 7 segment display. This is to show the number of the dice when it's rolled. Then we have the LED to indicate the rolling and the binary number. Next, we have one input, the button. The button is functioning to indicate that we have thrown the dice. Now, I will demonstrate how the board works. So, when we press the button, as we can see on the 7 segment display, the number will keep rolling until we let go the button. As you can see, the number will be randomized every time we push the button and hold it.
Okay, hi, I'm Azri and I will be explaining the first half of the digital dice program. So, this program simulates a 6-sided die using the 7-segment display on the Dragon 12 board. To start, we first need a place to store the dice value. As you can see, at memory address 1000, I reserved one byte called count. This variable holds the correct number 1 through 6 that will eventually be shown on the display. Now enough for the setup. Before the main loop begins, I have to configure the microcontroller ports. I do this starting at the label start. At port B, I set this to FF to make it an output. This port controls the individual LED segments of the display. And next at port P, I set this to 0F to make the lower 4 bits outputs. This port controls which of the 4 7-segment digits is turned on. And lastly, at port H, I set this to 00 to make it an input. This is where our push buttons are connected. There is a specific requirement for this board. Port J bit 1 or PJ1 controls the hardware driver for the 7-segment display. I use B set to make PJ1 as an output. Then I use B clear to drive it low. If I didn't do this step, the display will remain completely off, regardless of what I set to port B. And once the hardware is ready, I initialize my count to 1 and enter the first state labeled display static. So this loop does two things. Firstly, refresh the display. It calls the JSR show digit to keep the number visible on the LEDs. Next, it pulls the button. It constantly checks if the user has pressed the button. And I check the button using active flow logic. Firstly, I load port H. Then I use NB #01 to mask everything except bit 0. If the result is 0, it means the voltage drop to ground, so the button is pressed. So, the program then jumps to the shuffle label. If the result is not 0, then it means the button is not pressed, and the program loops back to display static, waiting for the user.
Next is the shuffling mode. So, this loop runs only while the button is held down. It increments the count variable by 1. If the count reaches 7, it resets it back to 1, creating a cycle of 1 to 6. It updates the display and waits 20 milliseconds so the rolling effect is visible to the human eye. Once the button is released, the program jumps back to the static display, freezing the last number shown. For the display command, the show digit subroutine translates the dice number into the specific electrical pattern need to light up the display segment. It uses a lookup table, which is seg table, act like a dictionary containing the hex code for number 0 to 9. The code calculates the correct address in the table based on the current count. Send that pattern to port B and turn on the rightmost digit using port P.